All right, we are back with more trig identities. Today we're going to discuss the sum and difference of angle trig identities. And we're going to start by comparing what we know about the unit circle to some given angles. So sine of 75 degrees and cosine of 15 degrees. Those values are not given angles on the unit circle. However, we could add two different angles like 30 and 45 to equal sine of 75 degrees. Like, we can do that, right? We could also find two angles to subtract, which would be, let's say, 225 minus 150. That could also equal sine of 75 degrees. If we needed to get 15 degrees because it's less than 30, our first value up from 0, in that case we would have to subtract 45 minus 30, or you could write that as 45 plus a negative 30 to get you to equaling cosine of 15 degrees. So we are going to use our sum and difference formulas, and I'll write those as we go through so we can practice some of these examples. And the first that we're going to do, the first 3 or 4 of them, we are going to expand, and then the remaining ones we're going to condense the formula. So for cosine of 75 degrees, again, I want to write that as cosine of 45 degrees plus 30 degrees. So I need to use the sum of the cosine's formula, which is cosine of the sum of two angles equals cosine of the first angle multiplied by cosine of the second minus sine of the first angle multiplied by sine of the second angle. Okay, now we have our angles, so we're going to use cosine of 45 plus 30. We're going to substitute those angles in for the u and the v in the formula, and then evaluate on the unit circle and simplify. Okay, so our formula will be cosine of 45 multiplied by cosine of 30 minus sine of 45 multiplied by sine of 30. All right, what is the value of cosine of 45 degrees? X coordinate there is square root 2 over 2. What is the value of cosine of 30 degrees? Again, the x coordinate at 30 degrees is root 3 over 2. Those two get multiplied together. Minus the product of sine of 45 and sine of 30. So sine of 45 degrees, the y value at 45 degrees is root 2 over 2. And sine of 30, the y value at 30 degrees is 1/2. All right, now we just got to multiply together and combine like terms. So square root of 2 multiplied by square root of 3 is the square root of 6. 2 times 2 is 4. Minus square root of 2 times 1 is the square root of 2 over 2 times 2, which is 4. So I have square root 6 over 4 minus the square root of 2 over 4. As one simplified fraction, it is the square root of 6 minus the square root of 2 all over 4. You're done. That's it. All right, our next one, sine of 165 degrees. So for this one, we can either add or subtract two angles. Let's just stick with addition. Most of us do fairly well with that. So looking at angles on the unit circle, we could add 30 degrees and 135. We could also have 45 degrees plus 120. And we could also pick some to subtract as well. But again, let's stick with addition. And let's go ahead and do sine of 30 and sine of 135. So the sum of sines, sine of u plus v, is sine of the first multiplied by cosine of the second plus cosine of the first multiplied by sine of the second. And I had to squeeze that in. Sorry, that's super teeny tiny. I wrote too big for the first one. All right, let's substitute in what we're using. We're going to do sine of 30 degrees plus 135. That will be sine of 30 multiplied by cosine of 135 plus cosine of 30 multiplied by sine of 135. Okay, so sine of 30 is, we just did that one, 1/2. Cosine of 135 degrees is negative square root 2 over 2. Plus cosine of 30, we just did that one. In the previous example, it's the square root of 3 over 2. And sine of 135 is positive square root 2 over 2. Again, those are our x and y coordinates at 30 degrees and 135 degrees. Multiply and then combine. The first two terms multiply together to give us negative square root of 2 over 4, plus the back two terms multiply to give us square root of 6 over 4, giving us a simplified answer as negative square root 2, oopsie, I wrote a 6, excuse me, negative square root 2, and then plus square root of 6 all over 4. There's nothing else to simplify. You can't do any more. All right, let's do a couple more. Sine of 255 degrees. So can I subtract anything to get me to 255? Because I want to try a subtraction one. What's 300 degrees minus 45 degrees? That is 255. Great. Awesome. We found it. So we are going to do the difference formula. It looks similar to the sine of some of the sines. It just has a minus sign in between. So sine of u minus v is sine of the first angle multiplied by cosine of the second minus cosine of the first angle multiplied by sine of the second. Okay, and we are using 300 degrees minus 45. Okay, so when we substitute in, remember this is kind of like plus a negative, right? Okay, so I want to do sine of 300 cosine of 45 minus cosine of 300 and then sine of 45. All right, so thinking about this value, we hopefully should get a negative answer in there because in quadrant 3, our sign would be negative. So sine of 300 degrees, that's in quadrant 4, and it's negative square root 3 over 2. Cosine of 45 degrees is positive square root 2 over 2. Minus cosine of 300 is positive 1/2. And sine of 45 is positive square root 2 over 2. So this simplifies to give me a negative square root 6 over 4 for the first term's product, minus square root of 2 over 4 for the second term's product. And that simplifies to give me negative square root 6 minus the square root of 2 all over 4. Okay. All right, and then our next example, cosine of negative 45 degrees, we are going to have to use subtraction. So if you guys keep this simple, like 0 minus 45, yep, that equals negative 45. You could also do 45 minus 90. That would also give you a negative 45. Okay, so the difference for our cosines. Now, pick up this pattern that we have for cosine. Cosine of u minus v is the product of the cosine of the angles, cosine of u, cosine of v, plus cosine changes its sign. Sine stays the same. And then plus sine of the first angle multiplied by sine of the second angle. Alrighty, so cosine of, what are we doing? 0 minus 45 is going to be cosine of 0 multiplied by cosine of 45 plus sine of 0 degrees multiplied by sine of 45. That's a 5, I promise. All right, cosine of 0 is 1. X value at 0 degrees is 1. Cosine of 45 is the square root of 2 over 2. Sine of 0 is 0. Yeah. And then sine of 45 is the square root of 2 over 2. Okay, cool. So the back term, 0 times square root of 2 over 2 is 0, and 1 times square root of 2 over 2 is the square root of 2 over 2. There we go. Now think about that for a quick second. Where is cosine of negative 45 degrees? That's going to be down in quadrant 4, and it's equivalent to 315 degrees if you go around the positive direction, and cosine is positive in that angle. Good job. All right, in numbers 5 and 6. So real quick, number 5, that one's not going to work in order to give us a value on the unit circle. That is a half angle, and we're going to do those later. So we are going to omit number 5. Yay! And then we're going to look at number 6. So for number 6, we have sine of negative pi over 12. Okay, so think about where that's going to be. Positive pi over 12 is here in quadrant 1, so negative pi over 12 is going to be in quadrant 4, and sine is negative in quadrant 4. Okay, now the next thing is there's not two, there's nowhere on there that we have a pi over 12 on the unit circle. So we need to look at our radians that we have, let's just look at quadrant 1, pi over 4, pi over 6, pi over 3, pi over 2, and let's convert any or all of those to have a denominator of 12 so we can figure out what to use. Pi over 6 is equivalent to 2 pi over 12. Pi over 4 would be 3 pi over 12. Pi over 3 would be 4 pi over 12. And pi over 2 would be equivalent to 6 pi over 12. Okay, so I need to pick 2 of them that when I subtract, give me a negative pi over 12. So I can do 3 pi over 12 minus 4 pi over 12, or I can do 2 pi over 12 minus 3 pi over 12. It truly doesn't matter. You pick whichever one you like. Let's do sine of 2 pi over 12 minus 3 pi over 12. That's what we're going to do, and we're going to expand that difference formula for sines. I'm going to go back and rewrite this in terms of the values we have on the unit circle, so I remember which ones to look at to get those x and y coordinates. So sine of pi over 6 minus pi over 4. All right, the difference formula for sine, it's sine of the first angle multiplied by cosine of the second minus cosine of the first angle multiplied by sine of the second angle. So sine of pi over 6 multiplied by cosine of pi over 4 minus cosine of pi over 6 sine of pi over 4. Alrighty, sine of pi over 6. The y value at pi over 6 is 1/2. Cosine of pi over 4 is the square root of 2 over 2. Minus cosine of pi over 6 is the square root of 3 over 2. Yep. And sine of pi over 4 is the square root of 2 over 2. Okay. When we multiply the first two terms together, we get the square root of 2 over 4. And then minus multiplying the back two terms together gives me square root of 6 over 4, giving us a simplified answer of the square root of 2 minus the square root of 6 all over 4. There we go. That is expanding using the sum and difference formulas. We'll come back for another video doing condensing sum and difference formulas, and then we'll also look at some values that are not on the unit circle.